We have had Gaurav Sen on our channel multiple times for system design mock interviews. He has also interviewed me and I have also interviewed him multiple times. And he is the CEO of InterviewReady, which is again known for system design. But we all know that Gaurav started with competitive programming. He started his YouTube channel with DSA tutorials. He used to be a great competitive programmer. Now, considering that he has entered into system design space, he hasn't done any DSA practice since 2 years. And in this mock interview, I'm going to ask him a really, really hard question. So let's see how he does without any further ado. Let's start the interview. But before that, just mentioning that in case you're buying Interview Ready, don't forget to use the coupon code KT to get additional discount. Let's get started. So you're given a binary matrix and the task is to find whether row swaps or column swaps will give you the maximum size submatrix with all ones.
Okay, will give us the maximum submatrix size
Yes.
with all ones.
Yes. So you can swap any two rows or any two columns. Okay. And you have to tell which one will give you the maximum size.
And I can do only one row swap.
Yeah.
Okay.
One row swap or one column swap.
Okay, so given a n cross m matrix of binary digits, zeros and ones, I have to identify which row swap or column swap will give me the largest submatrix in terms of area, which has all ones.
Okay. You can make as many row swaps or column swaps, not just one.
Okay, as many as I want. Okay, as many row swaps or column swaps to generate the largest possible rectangle of ones. I mean submatrix of ones. Okay.
Yeah.
Okay. Mm, I'll take a minute to think about this.
Yeah.
So okay. And what do I need to report? I need to report the number of row swaps or column swaps.
You can just tell whether row swaps or column swaps, like just that for now.
Okay, okay. Just to confirm, once I start with once I do a row swap, I cannot do a column swap. Like it's either only
Yeah.
row swaps. Okay, okay.
Do you want to share your thought process on
Yeah.
that?
I'll just a second. Sorry. Can I share my screen?
Yeah.
Okay. So my thoughts are going something like this. I have a matrix. What I'm considering right now is what happens if there is a row swap. If I take this row and swap it with this row. So this I'm just trying to understand how is a row swap affecting the area of the largest submatrix having all ones. So if it has all one here and it has all one here, and I have zeros in between. So how do I know that this is the right swap to do, or this is the equivalently good swap? Uh, Maybe the sum of the entire column that could help me. The sum of the row won't help me, but the sum of the column, the largest. I'm starting to think in terms of if I take the sum of these numbers and I get 2.
I say You don't have to tell me the answer. Which rows are you swapping? You can swap any row. I don't care. You just have to tell me that which one will give us the better result, row swap or column swap for now.
Okay, okay, yeah, okay, that makes sense. Okay, okay. I'm just looking at this idea. Let's say we have the number something like this. Okay. At this point, what I need to do is I need to, and also the submatrix in terms of area, right? So if I have the area as A cross B, this has to be largest.
Yeah.
Okay, yeah, okay, okay. Hmm. Okay, I'm not getting any idea around this, but I can try one thing. I'm still thinking about in terms of sum. If I take the sum of all ones for every column, then I'm getting 2, 3, 3, and 2. Um, and if I do it vertically on this side, then I get 4, 1, 1, and 4. Okay, so what does this, can this help me in any way? Can I say that the minimum number of,
Uh, okay. Can you focus first on row swap, like what is the maximum area you will get, and focus separately on, swapping columns, what will be the maximum area you will get? Let's focus on both separately.
okay, okay, okay. If I start swapping rows, then I'm going to see that no, but I cannot, just looking at the sum, I cannot say whether it's going to be 4 plus 4, like 4 into 2, because it could be that the ones are here. So with a new, if all of these are zeros, then that won't work. I'll have a 4 here also, and I cannot report which is the largest, whether row swap or column swap is doing it.
Let's focus first on row swap. That what is the maximum area that row swap can give us?
Okay. Yeah, I'm actually okay. So if let us say we do row swaps, uh, let's just start with one row swap. Okay. The maximum area that we can get is, in this case, this row and this row. Yes. So actually, a single row swapping here. Yeah, the maximum area is 8. In that case, it will become this entire column once I swap it. Once I swap these two rows. Okay, and in terms of column swap, the maximum area is going to be the same. Basically, there was no improvement. It is still 4. This will be the largest one, or this will be the largest one if I do column swaps.
As you said, the counter won't be the correct measure, right? Because say out of four, only two were ones, like two and two. So you can't really say whether those two were exactly on top of each other, right? When you do row swap. So how are you going to solve that problem?
Okay. Mm. Okay, if I use a greedy approach with the largest subarray of ones, uh, is that helping me? Then I find another, the second largest subarray, no, they may not have any match. And I also have a feeling that if I take the largest subarray with ones, the other subarrays, I mean, matching them may not give me the largest submatrix. Okay, can I use some sort of dynamic programming here to? But you just need row swaps or column swaps, which is more efficient. Okay, okay. Let me try something else. Like, what can I think of over here? Let's try a brute force approach. Um, let's try n factorial, which is basically, yeah, try every possible combination of this matrix in terms of rows and every possible combination of this matrix in terms of columns. So that is n factorial uh, plus m factorial, and then, yeah, so that would be uh, into n. Okay, so this is going to give us all possible combinations of this matrix, both rows and columns, and then I can give you a straight off answer. Okay. Now can I try to reduce this? Can I make this more efficient? Or in fact, I'm seeing there is an optimization because you're just asking me whether it is rows or columns, not whether what is the largest size of the matrix. But okay, let's start here at the very base here. Then okay, can I make it more efficient here? If a row only has zeros, no, that is too much case by case, because if it has ones, it may not match.
Okay, let's see. When you swap any two rows, what exactly happens then? Okay, take any two rows and swap them.
Okay, so when I swap, let's say 1 1 0 1, and
Mhm.
1 0 1 1, and this is 0 0 1 0 and 0 1 0 1. Okay, now when I swap, okay, actually I'll change it slightly. Okay, I want the largest subarray. Okay, I'm just trying different combinations here. Okay, now I want to swap for the largest possible subarray. I need to swap this with this. So the new array that I'll be getting is 1001, 0010, 0111, and this array which is 0111. Okay, yeah. So when I swap a row, what happens is the the number of some digits change in this. The sum of it changes. Yes, the sum changes. Everything changes. The entire row changes.
So, what exactly remains constant? See, when you swap two rows, then you need some consecutive ones on, like on a particular row, right? Together. That's what you want. Maximum number of rows in a particular row. Maximum number of ones in a particular row. Right.
Yes. The intersection should be the highest of these two. When I swap two rows, the sum of the columns remain the same. If that matters.
So maybe you can do some pre-computation before swapping the rows so that you will know that the number of ones in a particular row will remain same. Like,
Okay, let me try that. If through pre-computation, I can say this is three, this is three, and two, and one. After this also, it remains the same. It has to be one, two, three, three. So, but
But
the
that
intersection.
will remain same, right? When
Yeah.
you're swapping rows. So this
Yeah.
will remain same.
That's correct.
It will be the opposite thing in a particular row.
Okay, in a particular row, let's say this is three, but three is not really helping. So I have to. Should I take segments out of it? Segments. Okay.
say in a submatrix of all ones, you need continuous number of ones, not just the count, right? So instead of storing it in a single array, like
Right. Right. Uh, what is the largest submatrix I can make is one thing. Can I break it into segments? Can I take this thing and basically the count of ones have to be increased in in some segment. The okay. Number of okay. So let's say I have this array n cross n. Uh, okay. One of the things that I can do is how many ones exist. So for a 1 cross 1 cell, the number of ones which have to exist are 1. For a 2 cross 2 cell, the number of ones which have to exist are 4 for it to be the largest possible. And then from 4, I can check around it also. Okay, here I'm trying to break it into segments. The other thing that I can do is I can, every time I do a row swap, I can do some sort of a BFS. Is that to find but then I have to basically do a BFS on every one to find all the largest section having only ones. Okay. I'm actually not the place where I'm stuck is I'm not able to see where. I mean, how can we tell whether swapping a row is helping us find a section having ones? So like how is a row swap? Okay, let me first try to answer the question: how is a row swap helping at all, or a column swap helping at all? I cannot find a logical way to think of how do I take a row and put it in the right place. Should the number of matches in that row increase? Okay, if I take common indexes having ones for two rows, that is one indicator. If but an entire submatrix. So if I take a row and I break it into sub arrays of zeros and ones, and there is row number 2. These two might not be row 1 and 2, they might be different sections. So this has 0, this has 0 0 0 1 1 0 0 0 1 1. Is this helping me?
Okay, Gaurav, if you could sort the rows tip on a particular basis, what that basis would be? It's a huge hint. You can sort the rows. Now, what would be what would be the pre-computation that you would need to sort the rows? On what basis would you sort it?
Okay. If I could sort the rows, yeah, that can occur through swaps. Okay. Uh, Let me try to figure out what kind of pre-computation will help here. Uh, the first one on this side, no. Number of ones, no, that's not helping. Uh, I'm thinking of a two-pointer approach also, where we are going from, we have the first section. It has, let's say, 1 1 1 1 1, and then we go upwards, and then we see how many of these survive. That's not the way to do it. There might be some ones here. Is this screen visible also? Yeah, it is. Okay.
Yeah.
No, I don't think I'm able to get any solution to this. Uh, okay, okay. If I can sort the rows, on what basis will I sort them? This is a 2D matrix.
When will you get the biggest rectangle, right? If you're sorting them, you have to make sure that you have maximum number of continuous ones on the right side, like column wise, right? In a particular row, if there are maximum number of continuous ones together at a particular point, when you sort according to that,
Okay. All right. Okay. I think I'm now pretty much half the answer is given. Still, I'm not 100% convinced. So, I'll basically what's happening from what I can understand is, let me try this new thing, prefix sums. I don't know if this is correct. Let me just give it a try. Okay. Or let me do it with the old array over here. Yeah. Let me try prefix sums here. So, how many ones do you have on your left? So for this, every row will have prefix sums. How many do I have on my right? So that is one here, one here, one here, and zero here.
you need continuous ones in a submatrix.
Okay, yes, that's true. So how many rows do I have on my right? 0, 0, 1, 0. What about this one? It has 3, 2, 1, 0. Okay, that. And how does this help? Uh, what if a what if this also has a 3? So then I say 3 and 3 match, which is perfect. If it was 4, then also it is okay, because 3 and 4 at least they'll match with each other and produce a submatrix of size 3 into 2. Okay. Yeah, that's true. They'll produce a size 3 into 2. And if there is already something else also, okay, so for every, okay, let me try to produce another matrix from this of prefix sums. This comes out to be 0, 3, 2, 1, 0, 0, 1, 0, 0, 3, 2, 1, and 1, 0, 0, 1. Okay.
Just to be clear, this is not prefix sum, this is number of continuous ones on the right side.
Correct. Yes. Yes. So in this case, now swapping rows. Okay. Now I will say that from the left hand side. Okay. Now why am I swapping rows? Because I'm looking column wise. I'm looking on the right. Okay. Now and looking from the left, would it make any difference? No, because they would be continuous ones. Okay, so mirror image is taken care of. I'm going row wise, so therefore I'm looking at it this way. Okay, now how do I find which rows to swap? Okay, can I say that the largest, this number and this number should be picked up? Okay, if I'm swapping rows, what if there is a new row which is 3, 2, 1, and then 0, 0, 0, 0, and all of this is 0 here? What do I do then? Or if I have a 4, 3, 2, 1, and all this stuff is 0, what do I do then? I need to find a number over here having the maximum number of, having the largest number from 4. With that, it can make a submatrix of size 4 cross 2. Okay. And if I find multiple 4s or numbers greater than 4, then I know the number of rows having a number greater than 4 in this index can contribute. So if there are x rows, then it will be 4x. That will be size of the submatrix I can create.
This is why you sort. Like,
Okay. So yeah, if I sort the rows, now how will I sort them? On For this column, I can sort them. For this column, if I sort them, then yeah, if I sort them for this column, then that may give me this and this together. So for every column, I sort. Okay, that gives me the rows in descending order. I keep going up, and I okay. Uh, yeah, no. If I've sorted for every column, then I have the highest down below. So from the top, I can take the 1, 2, 3, 4 stuff like that. I cannot. I have 5.
what is the formula of area?
Length into breadth.
So
I have breadth with me, or one dimension. The other dimension has to be, no, but I have breadth in ascending order. Let me try that out. Let me say there is 4, 3, 2, 1, and there is 3, 2, 1, and there is 3, 2, 1, and 2, 1. So now what is the largest rectangle I can make? This is the largest rectangle I can make. Okay, so for every column, if I sort, no, then I can have a 1 also here. What do you do then? What about this rectangle? It's an area of size 9. It seems to me like there is some, you can actually, the factor of 4, you need to find with.
Don't think of optimizing it so much. It's okay if you traverse it once more. All you have to calculate is length into breadth, right? Matlab, you just want the maximum value of length into breadth. You already have like number of continuous ones. So if you have like 4 ones towards right, okay, let's go from the top. Okay, so let's say you start from 2, 1, 3, 2, 3, 2, 4, 3. Now all the rows below have at least 2 continuous ones on the right side, right? So at least breadth 2 is possible.
Okay.
So
Okay.
for
So if I,
length 4.
okay. So I go from the top. Yes, you're right. I see 1, and then I say that at least this much is possible. Okay. Then I go down and I say at least this much is possible. And then I go down and I say at least this much is possible. And it remains like that till I keep hitting 3. Still I hit 4, and then I say at least this much is possible. Okay. So and then I keep updating if required. I mean, if this area is greater than what I had earlier, then I'll keep updating it. Okay. Okay. Yeah, that can be done. So okay, this makes sense. Let's say I sort. First, I find max number of ones or continuous number of ones for every index to the right. Okay, for this I need to do a scan for every row. From the right, I'll keep starting and I'll keep incrementing the counter. The moment I hit a 0, I make it 0. So okay, that is one thing. Now I say that for every column, sort row by this number. Let's call it C of column. So every row has a sum array which has these counts. So sum of that column, we are going to sort the row by the sum of that column for every column. So this is a outer loop. Let's not focus on this right now. We are sorting the row, and then we are doing this computation, which is calculate max area of the given matrix. So calculate max area goes to the topmost, like this. If we sort over here, then there might be a lot of zeros also. So go to, we have sorted right now. So row 0, column, sorry for this, matrix 0th row and column. We need to keep checking I equal to 0 to n I. We need to keep checking whether if sum for this row and column, okay, the code will be that I have a particular max area equal to 0, and okay, this goes all the way to n. So just 1 second. I think I'm getting the code a little wrong. So the maximum area is initially 0. I have initialized it to 0. I'm saying for every row from the top 0 to n, do this. What is this? If the sum for this row and col is greater than 0, then I know that I can actually start looking at this as a potential area candidate. So okay, sum of I comma col into, that is this number here or here or here or here, into the remaining rows. So that is n minus I. This is the area. Okay, and then max area is maximum of max area comma area. So in fact this condition is also not needed. Okay, Is this pseudocode making sense?
It is.
Yeah.
I was hoping to be able to write the code like within that.
Oh, yes. Can I try doing that?
Yeah.
Okay. Just before I start doing that, also, I'm just starting to wonder. This will help me figure out the largest possible area for every possible column. That is one thing, and then the rows also will have the same issue. It's a mirror sort of thing. I can even transpose the matrix. Maybe that will be easier. And then finally, I have to just return which is larger. Okay. Complexity of this is for every row we are sorting it. Okay. I mean, firstly, we are finding the maximum number of ones, that is order n o n m. So let's say m and m are same, so n square. Now we have this new thing where we are sorting every row. So that is n square log n. Every row is every column is being sorted, and then we are finding the area. So inside that, for every possible column, okay, for every possible column, we are also doing something like calculate max area, which is okay. I think it will be easier if I actually write the code and see the complexity there. Okay. Okay, I'll stop sharing my screen now. All right. Okay. Let us say I have a function like calculate max. Okay. Calculate destination. Okay, and you're passing a matrix. Okay, now int x equal to row swaps equal to what did I do here? I made, did I swap rows or did I swap columns? No, I actually swapped rows. Okay, because I sort by rows. Sort A by rows. No, first I do some pre-computation. So I'll call this find sum. Can I assume that I have I have a function to transpose A, or should I write that down? I can, maybe I can look at that
It's
later.
okay.
Yeah.
It's okay.
Okay, I'll just if I get time, I'll write the transpose also function. Column swaps. Okay, whichever one is better, I'll output that. Now for int find sum, we are passing in a 2D matrix, and now I need to sort the rows. So firstly, I need to for an integer, okay, int continuous, what should I call this? Int runs, I'll call it, is equal to find runs in A. Once I have found the runs, I need to sort them according to row. So int matrix equal to sort the runs, and then finally for int I equal to 0, every column, int call. call less than n rows, m columns, call plus plus. Okay, now what I need to do is for every possible column, I'm actually, so this is for every possible column, I am sorting the rows by the sum. So this is not going to be inside it. It's actually going to be inside this. Okay, I found the runs. That's okay. Sort the runs on this column. That will be the answer, and then calculate max area. So int max area equal to 0 for int I equal, so for this is row, right? Yeah. Okay. Okay. For every row, I'm saying int area is equal to the sum of, what does sum mean? It means runs. Matrix of row comma column into n minus row. The current row I'm at, this is giving me the max area, and then max area equal to math.max area comma area. Yeah, this will give me the maximum area, and finally I have to return max area. Okay, so find runs is one of the things I need to do. Okay, even before this, I'll just note down the time complexity of this. For every column that is order n, I need to sort order n square log n, and also I'm doing something else here. I'm saying that order n square. Okay, order n square log n is what I'm getting from the time complexity. Okay, yeah. So,
Okay.
Okay, so which is not too bad actually.
I have a question. So when you are sorting all the columns, right?
Yeah, so for every column, I'm sorting that the rows by the sum of consecutive ones to the right for a particular column.
For a particular column, right?
Yes.
But for that particular column, so will it like sort within the 2D array itself, or wouldn't it be better if you could like copy that particular row into some other 1D array and then sort it out?
Yes. So when I say sort, I'm assuming that the internal this method call is actually creating a new array and returning me a new matrix.
Okay.
Which will be a 1D matrix, right, madam? Because you need a particular column only.
Well, oh yes, I just need a particular column. I don't need the entire array because that is not helping me. Right. So yeah, that is a huge optimization actually. If I took the entire array, then it would be taking pointers and creating a new array, which would make it n cube. This is much faster, n square. Right, n square log n then. Okay. Yeah, that makes sense. Okay. So, right, I don't think I'll be able to write the find runs and the sort function. Sort would be just, I have to take runs, and if I was somehow able to take this call, then that would be good. But yeah, it's a single array there. Okay, that makes sense.
Okay.
We are out of time. Anything else you would like to say?
I think this is a good question. I think despite getting a lot of hints, I have messed it up. But okay. all the best to me next time. Okay.
Okay. So Gaurav, here we know that you haven't coded in like 2 years, right? DS Algo. So I asked a hard question because I knew that you were a competitive programmer earlier. So what I thought would be interesting would be to see how competitive programmers can also be out of practice and take some time to come up with like a structured approach. Although the question seems at the top, like, if you just see it, it seems very easy because it's a matrix question, right? But when you really think about it, it has a lot of detailing that is hard for anyone to be done in 45 minutes, according to me. Uh, so code wise, yeah, like you had very less time to code, right? Like the last 5, 6 minutes, and you really used that well. And you were like me, like if you saw my interview, I came into a lot of pressure saying that okay, we have a timer going on and I have only 4 to 5 minutes left. So I was doing a lot of mistakes while coding. But you clearly were not doing that. Like you knew that okay, this is my solution, and you were doing that. So coding, I've given a 3 based on the time. So sorting 1D to 2D like is something that I think could be a part of code itself, and that is why I've given a 3. Otherwise, I would have given a 4 maybe in terms of code, right? Uh, Problem solving, yeah, I've given less because I gave a lot of hints, right? Like the firstly the pre-computation that store the values from the right or from the that part also, like I gave hints for sorting also, for calculating area also. So and these three I think were the major things, like right. One good thing that you took the transpose and you handled that well, that okay, let's do the column one. But that also I think in the starting I told that let's keep the two things separate, otherwise you were thinking of both of them parallelly, right? So for the audience I think sometimes it can be really helpful if you uh, divide the question, like think of just row swapping first and then column swapping. But yeah, like sometimes you try to do both together, so I guess you were trying to do that, right?
Yeah.
Yeah. Communication was good. You were communicating whatever you were thinking, like you were telling your thought process well, you were explaining well. Like why I have deducted those 2 stars was because even like communication happens both the ways, right? So even when I was giving the hint, like uh, it was taking a while to really understand that hint and then apply it to the solution, if you know what I mean.
Right. Yeah, yeah. It took. I mean, I wasn't honestly like personally. I don't think I was able to get any of the hints. In fact, yeah, I wasn't able to pick up on any of the hints to come close to the solution. Also, it was almost like pre-computation was. There were multiple times I think I got a hint for that. Sorting was another huge hint, but it still didn't affect me. I think at the end of the day, problem solving, even if coding and communication would be higher, it would still not be enough, because in terms of problem solving, there was not one step in the solution where I felt like I know what I'm doing. It was still like, okay, fine, this is sort of working. This solution seems to be working, but I wasn't confident that okay, I understood the logic of this. Like it was more like, okay, fine, this is run 3 simulations, seems to be working. Okay, let's go ahead.
But I really appreciate the honesty because see, we do mock interviews, but whenever I say mock interview to any YouTuber, the first response, if it doesn't go fine, we are not going to upload it. But I like how you are in the correct spirit and you are like, sometimes we do bomb our interviews. And considering that you haven't done any DSA practice in 2 years, it would be very unfair to expect you to do a very hard question live on a YouTube video. And I really get inspired because even when I am giving mock interviews, I'm very scared, right? Like uh,
Maybe I should be a little more, yeah.
no, but this is very transparent stuff. So I guess at least it helped people understand the thought process that what, this is how you can think. You can divide the question into two halves. You can think about row swapping first, column swapping, And then in row swapping, you can think of why sorting will help you, why pre-computation will help you, how you can calculate the area. This question has a lot of learning points to it. So I think uploading the video will still be very, very helpful. So that is the whole intention.
Awesome. This is good. I hope it helps other people as much as it has helped me. And I think out of this, if someone is thinking like, how do I improve my problem solving skills? If you're doing complex programming or problem solving practice, what's going to happen is when you're going to look at swaps, maybe one of the things which should automatically occur is sorting. That could happen. If you're working with 2D matrices, maybe pre-computation will come up. Calculating area was another thing, which is I found this question to be difficult, but not something that I could not have progressed towards in some way. Like I could have definitely come up with pre-computation and sorting, I think. But I think I was looking for the whole solution, the big picture all the time without going into the nitty-gritties, because of which I was not able to come up with any solution which was making sense. When I was thinking of greedy approach, sorting by numbers and all that, I was just looking at the larger picture and I was like, how is this helping? Instead of thinking about, okay, let's try it out. Which is I think the major reason why I was not able to get any of the hints past one single simulation. Yeah.
Right. So that also shows, right? Sometimes it really helps to break down to real details that, let's take care of a small problem now and then we'll see how things will work at the higher picture. I could see clearly that you are more bothered about, row and column. How can we do both together? And like even in sorting, like I think it was okay to just, copy the entire thing in a 1D array and then sort. But you were constantly, I guess, thinking that, how do we do space optimization and not store it in another complete array and do it there itself?
Yeah, I think personally, I was just thinking about there are some ones here and some ones here. How are they going to come together? So
Yes.
that part was really complex for me personally, but it makes sense. Yeah, good stuff.
But for audience also, like for matrix pre-computation, especially in matrix, there are 3 types of pre-computation that's very common. One is that you store the sum from 0 to ij. Another one is you store the continuous ones or the number of ones, like from left or from right, from top or from bottom. Like one sort of pre-computation that you were doing was the number of ones, like not the number of continuous ones, right? So these minor details is what can change the entire solution. Then instead of just number of ones, you should think about number of continuous ones, because that's what you need in this particular question.
Right. Okay. This is good, Kirti. Thank you so much. Let's.
Thank you for coming and doing this.
Sure. Thank you.
Guys, please do appreciate his spirit for honest mock interviews. There have been times with other YouTubers when I have recorded mock interviews, but we have not uploaded it because the YouTuber did not give his or her best. Gaurav could have also felt the same thing and he could have told me that, don't upload this interview, and we could have just avoided it. He is actually doing me a favor by coming on my channel and being interviewed, right? So look at his true spirit for mock interviews, and the video of course also shows that mock interviews can be really bad sometimes. We always don't give our best, and still I'm sure a lot of you got to learn a lot from the video, to understand the structure, the hints and everything. So please appreciate that, take it in a good sense, and check out InterviewReady because his system design content is just awesome. Don't forget to use the coupon code Kirti to get additional discounts. And please don't forget to like, share and subscribe. It will mean so much to me. Thank you.